Hey guys, if you hear noises in the background, my dog is fully misbehaving, so just ignore her. A him? It's a puppy. All right, so Sewell, Scary, and Rockall are small islands in the Atlantic Ocean in the same time zone. On a given day, the height of water in meters at Sewell, Scary is modeled by the function h of t equals 1.63 sine of 0.513 times t minus 8.20 plus 2.13, where t is the number of hours after midnight. The following graph shows the height of the water for 15 hours starting at midnight. At low tide, the height of the water is 0.5 meters. At high tide, the height of the water is 3.76 meters. All heights are given to two correct decimal places. Okay, so time is starting at 0, and then it is the number of hours after midnight. So the height of the water for 15 hours is shown here, and then we have a low tide of, I don't know what time it's happening, but it is a height of 0.5 meters. At high tide, I don't know what time that's happening, but there is a height of 3.76 meters. All right, cool. The length of time between the first low tide, so this and this, is 6 hours and m minutes. Okay. Find the value of m to the nearest integer. Okay, so this is a calculator question. I'm allowed to graph it. I'm going to do that so that way I could get these x's here, right? And then once I get those x's, I can be like, okay, the time between here is 6 hours and some number of minutes. So I'm going to do that. That's my plan. Okay. This is an IB exam question from last year, if I remember correctly. All right, so I'm in radians, good to go. 1.63 times the sine of 0.513 times x minus 8.20 plus 2.13. Okay, cool. And we are starting at 0, and it looks like we are going until for 15 hours, up to 15. And that looks just like the graph that I have over there. Cool. All right, so I'm trying to go from min to max. I'm trying to get those times. All right, so I have a minimum height of 0.5 and 3.76. Can confirm. Excellent. Okay, so those times that I'm sandwiched between are 5.14 and 11.3. Okay, so between that time frame, right, I've got, I wish I could change the settings on my graph so that way I'm not rounding so much. Yeah, okay, cool. So 11.26 and 5.138. Okay, perfect. So now I'm going to do 11.26 minus 5.138, and that's going to give me the kind of horizontal distance between those two times. Okay, so I have 0.122 minutes to work with here, right? I got to figure out what that translates to. Oh no, this is of hours, right? So I've got this much of hours to convert to minutes. Okay. And I do know that there is 1 hour and 60 minutes. I'm going to use this as my kind of conversion scale, right? So I've got 1x equals this times this. So I'm going to get 0.122 times 60, 7.32 minutes. And then depending on your float settings, so I think on like the answer key, like my float was rounding pretty early, so this could be off by a few minutes or seconds depending on what your graph is set to. So if you got anything in the ballpark from like 7 to 10, you're good. Minutes. So this is going to be our m value here. So m is 7.32 minutes. All right, cool. Between two consecutive high tides, determine the length of time in hours for which the height of the water is less than 1 meter. Okay, so I've got to go to the graph, and I need to kind of figure out where the two maxes are happening, right? Because it's two consecutive high tides. So let's get there. All right, I can see one high tide over here, but then the other high tide is like a little to the left of 0. So I'm just gonna take a peek and see if maybe that's the closest high tide. Yeah, it looks like there's a high tide over here. Okay, so I'm gonna take a look at that, see where that high tide is. Okay, so I see that between two consecutive high tides, I'm gonna determine the length of time in hours. So I don't need to convert to minutes here, which is pretty cool. The water is less than 1 meter, so I'm going to add a horizontal line at 1. I'm going to see where this graph crosses that line. All right, I'm starting to get a little bit of noise on here. All right, let's move this over here. There's a lot of, the dog is just really chewing on its bone. Okay, so I've got a time frame of 6.71 as the upper bound, and then the time for between that and the lower bound is 3.569. Let's see what that difference is. So I'm gonna do 6.71, 3.569, 3.141. And then again, on the key, my settings were annoying and they were rounding me a lot. So I think I got something different, like 3.1, whatever. But if you've gotten anywhere in the ballpark from 3.1 to 3.2, you should be pretty good on here. So the time is going to be 3.19 hours. Don't need to convert to minutes because they said in hours. So I'm good to go. All right. Now part C says find the rate of change. I want you to go ahead and underline rate of change because we know that that means derivative. Yes, derivative of the height of the water when t equals 3, giving your answer in meters per hour. Okay, so I can do I have the original function? Yes, I do. I can do h prime of 13, and I can evaluate this with menu for 1 derivative at a point and see if that gives me the answer that I need. All right, and then the value is 13. Okay, and then what was the graph stored under? F1. Okay, now I get negative 0.651. Okay, so I've got negative 0.651. That's meters per hour. Okay, so we would go ahead and say that maybe it's decreasing in height. Am I still recording? Yeah, okay, sorry, it went away. In height by 0.651 meters per hour. Cool. All right, and now my husband is furiously whispering to the dog. So, you know, the fun never stops. Shh, you two. All right, so on the same day, the height of water at the second island, Rockall, is modeled by the function h of t equals a sine of b times t minus c plus d, where t is the number of hours after midnight, and a, b, c, and d are all positive. The first low tide occurs at 2:41. Okay, so if I'm like thinking about this thing, right? They gave me, notice how they gave me minutes. So if I'm looking at hours on the x-axis, I have to convert those minutes. Okay. Anyway, so around like 2 and some change, right? That's going to be a low tide. And that low tide is going to be 0.4. And then I've got a high tide at 9:02, so that's going to be 9 and some change. Got to figure out those minutes. I'll do that in a minute. And that's going to be a high tide of 2.74 meters. Okay, so I've got a curve that kind of looks like time is starting at 0. It's going down first, going up, and then going down. Okay, I need to figure out what those minutes are. So how did I end up converting up here? I set up a proportion, but then it ended up just being me taking the decimal of the hours and multiplying it by 60 to get the minutes. So I'm kind of going to work backwards for that, right? I'm going to work backwards. So the 241, I'm going to do 41 divided by 60 because I'm working the other way now. And that's going to give me 0.683. So this is going to be 2.683. And then for 9:02, I'm going to do 2 minutes divided by 60. And that's going to give me 0.0333. Okay, so I have my 2 points now for the max and the min. The graph is a little funky looking, but you know what I mean, right? Okay, cool. So, my little sketchy poo. Okay, I got to figure out the amplitude. That's going to be A. Let's do the amplitude first. He's like the easiest to find, right? Okay, so this will be the amplitude. Okay, so I've got the highest high. That's going to be 2.74 minus the lowest low, 0.40. Then I'm going to divide that by 2, and I'm going to get 1.17. So the amplitude is going to be 1.17. So that's going to be the number out front. Okay. Now let's figure out, I feel like D, now that we have the amplitude D, or the midline, is probably going to be the second easiest thing to find out. Yeah, it's D on there. Always double check. Sometimes I change the letters, right? So I got midline. It's going to be the same thing as the minimum plus the amplitude. That's going to be 0.40 plus 1.17. That's going to give me 1.57. So the D is 1.57. Okay, so I got A, I got D. I need to find B is the period. Okay, so I know that B is the period, and that's going to be the distance from the minimum to the maximum, and then just multiply that by 2, and that's going to give me the period. So the minimum, or let's start with the maximum and then subtract off the minimum to get me that horizontal distance between the two, right? So I've got 9.0333 minus 2.683. That's going to give me 6.3503. And then that's the distance between a min and a max, and then I'm going to multiply that by 2 to get my period. So that's going to be 6.3503 times 2, 12.7006. Okay, and then I'm going to take that. I know that my period is equal to 12.7006, and that is equal to 2 pi over b, and I'm going to solve for b. So I now have 2 pi equals, I'm cross multiplying BTW. That's what you get for trying to be fast. I won't put it down there for me. That's okay. I'll just do it manually. 12.7006. Okay. And I've got 0.4947. 0.4947B. Sorry, is approximately B. And then I'm going to round to 3 sig figs, 495. Okay, so that's B. And then now I got to find C, which is my phase shift. That's my horizontal shift, okay? So the phase shift is kind of hard to conceive given the graph. So what I'm going to do is I'm going to use a point as a clue and see if that kind of helps me, right? So far I have like a ton of information on this thing, right? I'm trying to find the phase shift. So far I have my amplitude is going to be 1.17. So I have h of t is equal to 1.17. This guy is lowercase h, right? Rockall? Yeah. All right. So I got 1.17 sine 0. Get out of here. 0.495 was the period, right? Yep. And then I have, sorry, t minus c. I don't know what c is, so that's going to be the variable that I'm solving for. Plus the shift up, which is 1.57. Okay, so let's see if we got a clue point that we can use here. Let's use the min. All right, so the min was 2.683. What was the height though? 0.40. Okay, so I'm going to put in 0.40 is equal to 1.17 sine of 0.495 times t is 2.683 minus c is our unknown. Oh, close those parentheses, 1.57. Okay, so since this is, I tried to color code it and I didn't even put the right color in there. Okay, 2.683. So since this is going to scan for the first solution from the left, I'm going to end solve this bad boy, kind of save myself some time here. So the end solve command is going to be, actually let's write it up here so we don't have to rewrite it again. End solve this, comma, c. And I'm going to type that into my calculator, okay? So I've got menu 3, 1, and that's going to be 0.40 equals 1.17 times the sine, and just double check that you're in radians. Yes, good to go. Close those parentheses, plus 1.57, comma, c, and you should get 5.8563. Ripple, little buddy, he's being very rambunctious. So I've got my 3 sig figs, and that's my c. All right, cool. I've got every component to this thing now. So it says when t equals t, the height of the water at Sewell Skerry is the same as the height of the water at Rock Hall for the first time. Find the value of t. All right, so I'm basically taking the two functions, Sewell Skerry, and that guy's going to be h of t equals 1.63 sine of 0.513 times t minus 8.2 plus 2.13, and then Rockall, caw, I'm a seagull from Rockall. And basically what I'm trying to find is, I'm going to set these equal to z, or equal to each other, and find where h of t equals little h of t. All right, let's see where these bad boys cross. Here we go. So I think I already have Sewell Skerry in here, right? Sewell Skerry is F1. Perfect. So I'm going to delete this horizontal line because I don't need it anymore. Okay. And then I'm going to get rid of these to just kind of reduce some noise on the graph here. All right. Now I'm going to add the second graph, which was 1.17 times the sine of 0.495 times x minus 5.86. Close all those parentheses, plus 1.57. All right. So now let's see, what part are we looking at on the graph? Find the height of the water at Sewell Skerry. Oh, when time is, okay. So when time is equal to some unknown time here. That's what we're trying to solve for. The height of the water at Sewell Skerry is the same as the height of the water at Rockall for the first time. So remember, time started at 0. So let's back this guy up to 0, and then we're going to see the first time that these guys cross. All right, just to make sure we're looking at the right thing here, 4.164. Okay, so t equals 4.164, 3 sig figs, 4.164. No, hello, 4.16. Hee hee, sorry. And then I don't have to give it in minutes, right? Nope. The end.